Hello everyone, welcome in this lesson. In this video, you're going to learn about joint probability. So if you haven't subscribed, make sure you subscribe. So what do you mean by joint probability? Joint probability simply mean that it's the probability that both event A and B will occur together simultaneously at the same time. The probability that both event A and event B will occur together simultaneously at the same time. Probability that both event A and event B will occur at the same time simultaneously. So, probability that event A and B will occur will be equal to the probability of A intersect B. Remember, in our first video in marginal probability, we said that A and B, the relationship between A and A intersect B, this one is being associated by multiplication rule. And A or B, this one, the relationship between A or B and A union B, this one is additional rule. So we had probability that A and B will happen will be equal to probability A intersect B. This one can also be equal to the probability that A occur given that B has already occurred. The probability that A occurs given that B has already occurred times the probability of B. Or this one can also be written as the probability that B occurs given that A has already occurred, times probability of A. Now let's take for instance both independent events and dependent events. So when we tackle independent events, i.e., when we say that P, the probability of A occurring when B has already occurred, this one is same to say that it's the probability of A occurring. This one means that A does not depend on B. Are we together? Probability of A occurring when B has already occurred is simply the same as the probability of A occurring, which means that this one means that A does not depend on B, right? B has already occurred, so it's the probability of A happening. So A does not depend on B and vice versa. The same way you can say that probability of B occurring when A has already happened is the same as saying the probability of B happening. B does not depend on A. So that one is independent events. In our case here, we can say, based on this example, we can say under independent event, we can say that the probability of A and B happening can be equal to the probability of A times the probability of B. We just replace probability of A happening when B has already happened with probability of A, right? Or you can say the probability of B times the probability of A. Yeah, we just replace this one by this and this one by this. Let's look at a scenario whereby we have dependent events. In such a case, let's look at balls. When you're told, an example, when you're told that the probability, let me say, the probability of picking a red ball. Maybe you have some red balls and white ball in a basket. Then you're told that you are picking them randomly with replacement and maybe without replacement in the other question, right? So the probability of maybe picking a red ball when you are replacing with replacement, this one is independent. Why? Because if at all, let me say you had 4 red balls and you had picked 1 red ball, right? And you replace another red ball. It means the probability of the second pick does not affect the probability of the first pick because you have replaced the red ball. What if we say that the probability, if I know the probability of picking a red ball with replacement, without replacement, this one is dependent. The probability of second pick is dependent on the probability of the first pick. Why? Because if I told you had 7 white balls, if you pick 1 white ball, then you remain with 6. So if I told you will be picking the second toss, then it will affect the first pick, right? Without replacement. The same case when you talk about coins. When you're talking about coins, then that means it's independent. Let me say you are told that this one is independent. Because why do you say that it is independent? Because the probability of the second toast getting head or tail does not depend on the first toss. You can either get head or tail in every toss that you make. Either head or tail, either head or tail, right? So these ones are some of the examples of independent events and dependent events. So in our case, we had. I want to give you a critique analysis of how, if at all you see the probability of A and B, this one just imply that means that it's the probability of A intersect B, which means that they are simultaneously at the same what? At the same time. Right? And if you see that the probability of A, B, this one simply mean it means that it's the probability of A first happening, and then you follow it by B happening in the second place. Probability of AB. You said that A happening followed by B, or B happening followed by A. Yeah? When you say the probability of B, A, this one means B happening first, and then A happening second, right? So that will imply that probability of A and B can also be equal to the probability of B and A. But the probability of A and B cannot be equal to the probability of B A, according to my explanation in the first in here. This one cannot be equal to this. And in some scenarios, then we say that the probability of A and B happening, in some cases, no, it can also not be equal to the probability of A, B happening. If all this cannot be equal to this, then this can also not be equal to this one here. See, in my next video, let's tackle some examples under joint probability. Thank you for your time.